reliability results presentation that we gave to management after the first cycle of performance testing. And let's focus in on these IMAP mail servers here. So the simulation, this simulation tool, by the way, which was Hyperformix, predicted that there'd be 45% server utilization at 25,000 users. Okay, and that's their prediction. And they predicted that the IMAP servers would saturate at 40,000. In other words, it would hit the 75 to 80% utilization, which is usually about where bad things start happening. So, did we see the 45% at 25,000? Yep. There's 41% utilization there, because this is idle, right? So it's 100 minus 59, and 45%. So that's actually right on the money there, right? So the test data and the simulation are in sync at that point now. And then also look at the 40K, and that's means that our simulation might, or our test might bear out that simulation, but then that would be a case where we would have a discrepancy with the expected results, because the expected results were to be able to support 50,000 users. And not only were we able to do this at a high level in terms of resource allocation, we were able to drill down to the individual transactions that were being carried out, IMAP transactions that were being carried out, and look at what's the simulation versus what's the test observation. So you see here with the Connect, you know, those guys are pretty well aligned, 0.74 versus 0.77. But you get the banner, obviously, wow, you know, you got a big discrepancy here. So somebody's going to have to look at that, understand what that is. Authorized, you know, kind of, sort of, it's not a straight line there, but it's close enough, right? It's a fairly small discrepancy. Here, this one is another one that's like, yeah, you know, if you squint and hold up one finger, it kind of looks the same. You know, they don't seem to be a big discrepancy there, though that's, you know, more significant than some of the others. But, you know, this guy is just, this is the killer here. You know, this is an eighth of a second, right? 125 milliseconds. This is 6 seconds. So, you know, we're talking about an order of magnitude type of swing indeed there. So this is the kind of cross-checking that we're able to do, really, really fine-grained cross-checking. Now, this kind of thing is not going to happen by accident. You are going to have to design the tests and the models so that they spit out the same kind of data that you can compare against each other. It was not an accident that there were simulation clocks or meters, if you will, keeping track of this exact set of 5 transactions here, nor was it an accident that we were very carefully timing that. We built our tests to make sure that we could have comparability between the test results and the simulations. Now, tools. You need tools for performance, load, and reliability testing. I suppose that someday or another I'll be consulting with a client and I'll actually see a situation where somebody's doing manual performance, load, and reliability testing, and that makes sense to me, and I say, oh yeah, that's right, that's the way to do that. But most of the time, well, every time that I've seen this happen, someone doing manual performance testing, after enough digging, I could satisfy myself and usually them that it was not legit. So you're going to need tools, and you have options here. Now, of course, there are commercial tools. We're all familiar with commercial tools because they have a marketing budget and they can make us aware of their tools. There are open source tools, which you'll have to actually go find, but they're out there. And there are custom developed tools that you build yourself. And you know, you might, in some situations, need a mix of these, a combination of these tools, because you'll find that any one of them by itself is not actually able to work. So I've listed some sources here for places to go to look for open source tools in case you're at a loss as to where to start, though of course just doing a web search, open source performance test tool, probably get you started. Now, the thing I'll mention here, because I see a lot of our clients making, well, not a lot, but some significant number of our clients making this mistake of, oh, it's free, so just download it and use it. No, you don't want to do that. You want to have a thought out test system architecture here. And our advice to our clients is always that you should evaluate the free tools that you accept as rigorously as you evaluate the ones you buy. So a story about tool acquisition not going well. This is a sad story, but it's a story that some of you might have heard before, and in fact a story that some of you might even have lived. I hope not, but anyway, we have a client that before they were our client, sent two people to a conference, a testing conference in the United States. And at that testing conference, there was an event called the Tool Expo. And the Tool Expo is basically a lot of free food and free booze from the tool vendors to people who were wandering around after the first night of the conference. And the salespeople are their pitch. Well, they ran into a very persuasive salesperson who, combined with the free food and especially the free booze, worked on them to convince them that they should buy this very expensive tool. And then when they got back to the office, they realized that the tool wasn't enough by itself. They actually needed somebody to write the tests, and so they hired a consultant through the same company. So you can imagine the consultant, the training company is very happy, right? So they now not only have they sold the tool, but they have a consultant there who's billing an hourly rate. And things went from bad to worse here now, because as the consultant got done building the tests, there was no transition plan. The consultant just got done and basically left. And further, what they were trying to automate was the graphical user interface of this engineering package, and it really wasn't the world's most stable interface. It wasn't that the interface was changing, but just that there could be multiple results that were equivalent, but they looked really different. So unless you happen to be an oil engineer, you could look at this stuff and say, oh yeah, that's clearly different. But an oil engineer, petroleum engineer, look at it and go, no, that's tolerable difference. That doesn't indicate anything significant. So the consultant then eventually left. There was no knowledge transfer, and the tools were basically unusable. They were used for a while afterwards, while they were still, it was in the process of rotting, but eventually they just rotted away, and the company was left out $500,000 and nothing to show for it, but a box. They didn't have a box on the shelf. So don't buy tools like that. That you don't want to make those kind of buying decisions. You should have a design for your performance load and reliability test system, and then you should be able to identify the specific tool requirements to build that system. And at that point, you're ready to start shopping for tools, armed with a list that tells you what needs to